Welcome to my fourth lecture on singly reinforced beam. I'll be doing this problem number three. Determine the lever arm and moment of resistance of a beam sections shown. Use M20 and FE250. Your M20 is your concrete grade and this is FE250 section you have to refer for calculating lever arm and moment of resistance. So we have first to calculate, first step is to calculate or to find. To calculate, first is your lever arm, second is moment of resistance, then input data. Second step is your input data. You have to identify what all input data are given in the problem. So your B, that is width of the beam, is given as 275 mm. Your capital is given as 425 mm. We have been given the clear cover as 35 mm. So AST also given. AST is 4 numbers, 16 dia bar. So total AST in terms of area, in terms of mm square, so AST is equals to 4 into pi by 4 into 16 square, that is d square. So d is your 16, so it is equals to 804.25 mm square. So AST given is 804.25 mm square. Yeah. We have then clear cover. So effective depth, small d is equals to capital D minus d dash. D dash is your clear cover. So 425 minus 35, which is equals to 390 mm. So your capital D, that is effective depth. Effective depth is 390 mm. Now we have effective depth, we have AST, we have the dimension of the beam. So now to calculate, now we'll calculating XU limiting. So the formula for XU limiting is XU limiting is equals to 0.53 D for 250 FA250. We have from where this formula comes. So 0.53 times your effective depth, that is 390, which is equals to 207 point 09 mm. So now we have our XU limiting. We need to calculate actual neutral axis. So formula for actual neutral axis, we need to calculate actual neutral axis NA, which that is our XU. So XU, we have formula for XU. XU is equals to 0.87 Fy upon 0.36 FCKB. AST we already have. Fy is your grade of steel, FCK your concrete grade, and B is your width of beam. So 0.87 into 250, and AST is 804. We have already calculated AST 804.25, then upon 0.36 into FCK is 20. FCK at concrete is 20. Width of beam is 275 mm. So XU is equals to 87.86 mm, which is XU limiting, hence the condition is satisfied. Hence condition is satisfied. So our XU actual neutral axis is less than our limiting neutral axis. Now we have our lever arm formula, that is, which is Z is equals to D minus 0.42 XU. Here your XU is your XU, this your XU actual NA, D is your effective depth, that is your lever arm. So I'll term it as lever arm for better understanding. So Z is equals to D is your 390, your effective depth is 390 minus 0.42 times XU is actual XU 87.86, which is equals to 390 minus 0.42876 8.42 into 87.86, which is equals to 353.45 mm. So we have our lever arm which is equals to 353.45 mm. Now we need to calculate moment of resistance. Moment of resistance. So moment of resistance is equals to either C into your lever arm, that is compression into tension, tensile force. So we have for T into lever arm, T into Z, where T is equals to 0.87 Fy AST into your Z. Z is 353.45. This is nothing but your tensile force. Fy is your stress. This is your area. So stress into area is nothing but your force, tensile force, and this is the factor for tensile force of steel, which is equals to 0.87 into Fy is 250, AST is 804.25, 353.45, which is equals to 61.83 into 10 raised to 6 Newton mm. So we'll convert it to kilonewton meter by dividing it with 10 raised to 6. 61.83 into 10 raised to 6 divided by 10 raised to 6 meter. So moment of resistance is mu is equals to 61.83 kilonewton meter. Now we have our moment of resistance. We have calculated lever arm. We have whether this moment of resistance is mu limiting or less than mu limiting. If this value is greater than your mu limiting, then we need to again redesign. So mu limiting, we have a formula. mu limiting is equals to 0.148 FCK BD square. FCK BD square, which is equals to 0.148. FCK is your 20 MPa, B is 275, small d is 390 square, which is equals to 123.81 into 10 raised to 6 Newton mm, which is 3 point meter, which is greater than mu. Hence satisfied. So the final results are Z liver arm is equals to 353.45 mm. Then mu, that is moment of resistance to 61.83 kilo. Hence we have come to the conclusion. So this was the problem. Hope you understood this problem. The next lecture I'll start a doubly reinforced section. Till then, bye. Have a nice day. Take care.